2, 1.
Can you give me
Yes, so
everything is good.
everything's fine. Yeah.
Well done.
Signal. So the particles are still there. We are super happy that we managed for the first time to transport antimatter out of this facility, in particular antiprotons, because this opens in principle an entire new universe for precision measurements outside of CERN.
You're all familiar probably with electrons and protons, and antiprotons are antiparticles for protons, which means that they are basically identical particles, but they have opposite properties like charge or magnetic moment. And what is special about antiprotons is that they don't exist naturally in the observed universe. That's why it's so very difficult to actually produce them and store them and to transport them. And we managed to do it today for the first time, to transport them around CERN in a truck, in a penning trap.
And what is difficult in this antimatter transport is, first of all, to keep the trap autonomous, to keep it cold, to keep it on batteries, but then to maintain the vacuum. Today we were transporting 92 antiprotons. To compare this with a grain of salt had something like 10 to the 18 protons inside. So compared to this, this is a billion times a billion less times a factor of 100 or 92. So these were only very few particles, but these particles are in principle, because our experiments are so sensitive, sufficient to do ultra high precision investigation. And this means we are inventing here a new type of precision microscope for antimatter particles, with which we can look for fundamental symmetry tests and search for physics beyond the standard model that might maybe even help us explaining why our universe is made dominantly out of matter rather than antimatter.
4, 3, 2, 1.